For those who have joined the live streaming today, I welcome you. I am Sivaraman and I give a brief introduction. 35 years experience in teaching chemistry. I was a faculty in SK Sumaya Vinay Mandir in Mumbai over here, and I was also once upon a time a faculty in Agarwal classes, which was one of the most famous classes which lasted for 50 years. I was there for about less than a decade. So we have I'm the founder of AKP Learning Solutions Private Limited. Our product is EduMate Plus. The channel EduMate Plus is a app for test and a test platform for JEE Mains, NEET, and MHCD. With this brief introduction, let's start. So I will be teaching you live streaming for you people who are in the last fag end of your 12th standard career, the inorganic part. Okay. Because that is the most neglected part. People generally tell the student you manage it on your own. It is not manageable because out of 45 questions in NEET, 15 inorganic, 15 organic, and 15 physical. That's how it is, what you call, distributed. Okay. So now, P block elements include groups. So let's start with first the basic introduction. When I talk about P block element, P block element includes group 13 to group 18. 13 and 14, that is, these two groups we have studied in the 11th standard. Now in the 12th, we will be studying 15, 16, 17 and 18, of which group 15 is a very major part. 16 is also major. 17 and 18 because they're inert gases, less chemical property. So there is no, what you call, not much reactions to talk about. Okay. I would want you to actually keep your textbook ready so you can mark some important points which I'm giving you here. I have my regular students also in the group. So P block element. Now first thing is, what are the first thing in this group? So what are the elements what kind of elements are included in this group? So that's the first MCQ that can be, which can be asked. First is in group, if you look at S, P, S, D and F, elements of the S, D and F are all metals. Elements of S block, D block and F block all are metals. So the first MCQ is P block includes all the non-metals. So that's the first thing in introduction you should know, that all the non-metals are present in P block. Is clear? Then the next is what? We come straight to group 15 elements. So which are the group 15 elements? Group 15 elements are nitrogen, phosphorus, arsenic, antimony, and bismuth. Nitrogen, phosphorus, arsenic, antimony, and bismuth. It's clear? Now, a very important point is you should know bismuth is the last stable element. So, last stable, because after bismuth we have polonium. Polonium is the first radioactive element. Yeah. Then nitrogen is a gas, phosphorus is a non-metal, arsenic and antimony are metals. Yeah. So this is how slowly we are going to study the properties. The first thing we talk about is occurrence. Okay, that's very important. So these are the elements, and we come to what? Occurrence. As far as nitrogen is concerned, nitrogen, dinitrogen. We never say nitrogen. When I say nitrogen, nowadays it is understood it's nitrogen atom. So this is dinitrogen. It exists as dinitrogen. Dinitrogen forms nearly 70% of. In the combined state, it is clear, very important, it is nearly 78%. Okay. And in the combined state, what happens? It occurs as nitrate. In the combined state, it occurs as nitrate. Okay. We will further on, when we study in detail nitrogen, we come across chili saltpeter and Indian saltpeter. Okay. So potassium nitrate and sodium nitrate. So these are two things which are going to come again. This is going to be repeated. The nitrogen next is phosphorus. When we look at phosphorus, one of the main source of phosphorus is bone ash. It also occurs as what? It occurs as fluorapatite. Ca3PO4 whole twice. CaF2. Okay. Bone ash is calcium phosphate. Fluorapatite. Now, they expect one of the kind of question they can ask in entrance exam is, you prepare a list of all the minerals and its formula. So that is one mark. See, these are factual questions which can be asked. Just clear. So you have fluorapatite. And then what happens is arsenic, antimony, and bismuth. They occur as sulfides. They occur as sulfides. Is this point here? Then what happens is the ores of, now bismuth is distinctly a metal. So ores of bismuth are. So what is a ore? Ore is something from which we can, mineral from which we can profitably extract the metal. That is the definition of an ore. So all ores are minerals, but all minerals are not ores. Is this clear? So ores of bismuth are bismite, which is Bi2O3, and sulfide, bismuth sulfide, which is Bi2S3. This is in general, we are talking about atoms. So now what happens is, here we are talking about electronic configuration. So we have nitrogen, phosphorus, arsenic, antimony, and bismuth. Now what I do is, you can't possibly remember atomic number of all the p block elements. It becomes slightly difficult. I follow this. So you have nitrogen, phosphorus, arsenic, antimony, bismuth. So what happens is, I actually remember only one, that is halogen, group 70. You have fluorine, bromine, iodine, and etc. So if you remember what is it? This is 9, 17, 53, 10, 17, 35. 35, this is 53, and this is 85. It's easy to remember. 9, 17, I have highlighted only one. So for every time you have 15, 16. So suppose what will happen? If this is 17, 16 will have 8. If it is 15, it will have 7. So simply deduct. So this will be 15, this will be 33, this will be 51, and this will be 83. So if you remember one, just go on. Last one, if you remember, then what happens? You go on subtracting one for each of the groups previous to it, it becomes easy. So this is a technique which I use. Now when you talk of nitrogen, you can have your own independent strategy. So nitrogen is what, 7. So the configuration is 1s2, 2s2, and then we have 2p3. So the outer shell configuration is 2s2, 2p3. Why am I mentioning the sentence outer shell configuration? Because electronic concept of valency says that the chemical property of an element is because of its outer electronic configuration. So many properties that we are going to study, we are going to explain on the basis of outer electronic configuration. So phosphorus will be 15. So it is 1s2, 2s2, 2p6, 3s2, 3p3. Then we have 1s2, 2s2, 2p6, 3s2, 3p6, 3d10, 4s2, 4p3. Then we have 1s2, 2s2, 2p6, 3s2, 3p6, 3d10, 4s2, 4p6, 4d10, 5s2, 5p3. So you see, 57, why did I not put 4f over here? Because when we teach you lanthanides, we tell you 57 is lanthanum. So 58 onwards only the 4f gets filled. Is this clear? So this is already 51. So sorry, definitely what happens is, this is before lanthanum. The next one we will have, this will be 1s2, 2s2, 1s2, 2s2, 1s2, 2s2. Then we have 2p6, 3s2, 3p6, 3d10, 4s2, 4p6, 4d10, 4f14, 5s2, 5p6. Then we have 5d10, 6s2, 6p3. So the characteristic outer electronic configuration is, so that's the next question we should know. That is the characteristic outer electronic configuration. It could be a very simple question. See, you should not think that in our entrance exam, all the 45 or the 35 questions are all what you call tough. Some are very simple. It is clear. The tough ones also we face. It is clear. But we try to sum it up while we are teaching only. Characteristic outer electronic configuration is NS2 NP3. Characteristic outer electronic configuration is NS2 NP3. So this is about electronic configuration. I'll give you about 2 minutes. Okay, Priya, when you finish, you tell me. So what happens is I can get time myself. So you can please take down this much, especially these points. Okay, these are points which are important for. Okay, then okay, this would be important because this would be important. Okay, mark. Okay. So what do we have? Now we are coming to the next point, that is periodicity property. A lot of questions can be asked in this. So we are coming to periodicity in property. So when you talk about periodicity in property, the gradual change in periodic property, the gradual change in periodic property, gradual change in periodic property is because of change in atomic size. Change in atomic size and change in, of course, the nuclear force of attraction. Nuclear force of attraction. Okay. I'm not looking at atomic size because there's only one sentence to say that atomic size increases as we go down. We come to the more important part, that is ionization. There is something that a question can be framed on this in the entrance exam. We have ionization enthalpy. Okay, delta REH, ionization. So obviously it is a gradation in property or a gradual change in properties depending on atomic size. So what happens is, as we go down, okay, so as we go down the group, what happens? Ionization enthalpy, what it decreases. Why does it decrease? Ionization enthalpy decreases as atomic size increases. Atomic size increases. So this is the first ionization enthalpy that I'm talking. So if I look at the value, I have nitrogen, phosphorus, arsenic, antimony, this. Okay. So the values of ionization enthalpy is, it is 1402 kilojoule per. All these values are in kilojoule per. I have to tell you, write down because there's a reason. Then we have 1012 kilojoule per. This is 947. And then we have 834. And then we have 70. So there is no problem with this. There is absolutely no problem with that. You can see as the atomic size increases, nuclear pull on the outermost electron decreases. So energy required to remove the outer electron decreases. So ionization enthalpy decreases. But if you look at, let us look at the third row elements. We have, why are we talking about the third row element? That will give us an idea of what we are going to, what is the question that they can answer. Why are we talking about the third row elements? We are talking about third row elements because they are the representative. They are the representative elements. They represent the group to which they belong. So we look at the third row element: sodium, magnesium, aluminium, silicon, phosphorus, sulfur, chlorine. Of course, you have argon. Argon is exception. It will have very high ionization enthalpy because it is inert. So when you look at it, the decreasing order of this thing, in this case, the decreasing order of ionization enthalpy is, you have sodium, correct? Now, third row, I have to tell you like this, that we have before nitrogen, we will take the group 15, sorry. We will have to adjust it like this. Third row elements is there, but then more important, I explain it last. So you have before this group 14 and you have group 15. and then we can work. So in terms of group 14, what do you have? Carbon, silicon, germanium, tin, and lead. And group 15, we have nitrogen, phosphorus, arsenic, antimony. So if I go by the general trend, group 14, it's clear. Group 15 should have had less ionization enthalpy as compared to what do you call group 14. But what happens is, here this is the problem. Group 15 elements. Now this is what I'm trying to explain, and then I'll explain the third row, the decreasing order. Group 15 elements have delta ionization enthalpy H1 greater than group 14. This is an anomalous behavior. I'm trying to be a little bigger than group 14. This is anomalous behavior. So we have the values. Suppose if I look at silicon, silicon has a value 786 kilojoule per mole. So automatically phosphorus should have had less than 786 kilojoule per mole. But the value of phosphorus is 1012. And then if you look at group, this thing, silicon, phosphorus, sulfur. If you look at sulfur, the value is 1000 kilojoule per mole. So you can see that group 15 is greater than that. Why? The reason is because it has configuration NS2, NP3. So we have the configuration NH2, NP3, group 15. What is it that we are having? NH2, NP3. This is half-filled configuration. This is half-filled configuration. Hence, it is more stable. Hence, it is more stable. It is clear. So, if it is more stable, energy required to remove the outermost electron increases. So, what happens? You will find that ionization enthalpy, what do you call? So, ionization enthalpy of group 15 will be more than the corresponding group 14. So, that's an anomalous behavior. So, that is a question we can have. So, we will have now it increases. Okay. Now that means what? When you look at third row elements, now I come to the point: sodium, magnesium, aluminium, silicon, phosphorus, sulfur, chlorine. So technically, it should have been that sodium is less than magnesium, less than aluminium, less than silicon, less than phosphorus, less than. But what actually happens is, magnesium has a 3s2 configuration, and here our friend phosphorus has 3s2 3p3. So they are extra stable. So what happens? They have more than aluminium. They are less than aluminium. If we say ionization enthalpy increases as we go down the row. As we go down the row, then sodium should have at least, then magnesium, then aluminium. But what happens is, it is sodium less than aluminium, less than magnesium, less than silicon, okay, less than sulfur, less than phosphorus. It's clear. So here you can see silicon, phosphorus, sulfur. You have silicon 786, then sulfur 1000, then this, and then chlorine. So this is the entrance exam question that they ask. The decreasing order of, the increasing order of ionization enthalpy in any row. I'll give you a third row. So this will be group 1, 2, 1, then 13, 2, and all that. That way. It is clear. So this is important for the entrance exam point of view as far as ionization enthalpy is concerned. It is clear. Please take down. Yeah, when you finish, you tell me because then I can time it out. Okay. So now what happens is next one that we are going to is there is slight one more this thing atomic. Yes. You can actually make a sheet of all this, one sheet so that you can revise before the exam. Inorganic chemistry, mostly we are going to have a lot of these decreasing order, increasing order, and all. So you just write it down somewhere in one diary. So what happens is you can keep on revising that, and you'll always know why you got that answer. Like for example, here also we're going to have something like that. See what happens is the next periodic property we are talking about is atomic volume. Atomic volume and melting point. Obviously, that's going to depend on. So when I look at nitrogen, phosphorus, arsenic, antimony, bismuth. So when you talk of melting point in Kelvin, so melting point in the unit of Kelvin, okay, this is 63 Kelvin, 317.1, 1087.5 Kelvin. This is 904 and this is 540. So this is a clear indication that there is no what you call perfect sequence. I cannot say as we go down the group, melting point decreases, melting point increases and all that. This is clear. So this is the trend. So it is mainly because of the packing. If you see nitrogen, it is a gas. So 63 Kelvin means it is A. And we have to convert nitrogen gas into liquid nitrogen will then convert into solid. So 63 Kelvin, it is not degrees, it is 63 Kelvin. Then what happens? 273 is 0 degrees, so this is solid. Okay. Then we have arsenic, all these are solid, so they will have it. Now here is the question. So what will happen? So nitrogen, okay, nitrogen will be less than phosphorus. But phosphorus will be nitrogen less than phosphorus, then phosphorus less than arsenic, correct? But arsenic is greater than bismuth, is greater than what do you call? The highest should be arsenic. Let's see. What will we have? 63. So, increasing order of melting. So, that's the question I'm trying to get. So, you have increasing order of melting point. So, this is the question we can anticipate in the end of the exam. So, 63 nitrogen is less. So, nitrogen is less than phosphorus, is less than bismuth, less than arsenic, and less than antimony, sorry, less than antimony, He, and less than arsenic. So you can see over here, since this is really varied, you can expect this kind of. So one thing, what is the other question that they can ask? Which element in group 15 has the highest element? Which element? This is another one which you can expect. Believe me, somehow I think people just say bismuth. It's a metal. So here we have a problem. So which element in group 15 has highest melting point? Okay. So it's an anomalous behavior. So answer is what? So your answer is arsenic. Nobody may ask you the value of that melting point, but they can always ask you the trend and which has the least. And since nitrogen is a gas, anybody can guess it out. That is not a problem. But when you're talking about solids, guessing becomes difficult because here how compact it is arranged and the metallic bond forces, all these come into play. And for some are non-metal, so there's going to be covalent bond, van der Waals forces. In metals, it's going to be metallic bond. So all these different forces are acting. So the values are going to change. This is clear. And that gives rise to anomalous trend, as I would say. And that gives rise to a question. So this is it. But when we come to boiling points, as far as boiling point is there, boiling point increases regularly down the increases regularly down the. So what you will have? Nitrogen less than phosphorus, less than nitrogen, phosphorus, silicon less than arsenic. Phosphorus, sorry, not silicon, arsenic, antimony, and we have this. For those, so this will be the trend. This is a regular trend, but there's nothing given. They've just given one, a statement somewhere in the corner. It regularly increases, but they can convert it into this is less than. They can convert it into a question like this. So this is how questions are framed. Please take down this. The whole inorganic chemistry is going to be this only. All the trends and all that we are going to see. Okay. So now, next is a very, very important topic. That is allotropy. Again, a lot of questions can be asked from the entrance exam point of view. So what do we have? We are talking about allotropy. Believe me, the first question that can come into the mind of the paper setter or will be the question they'll ask is which element? That is, we'll have nitrogen, phosphorus, arsenic, antimony, bismuth. They'll remove one of them in between. They will ask which does not show allotropy. And a student with just in that 1 minute will always say nitrogen because it's a gas. Because you've somehow been made to believe that allotropy is only for solids. But gas can be converted into a solid. So the most important is which element in group 15 does not show allotropy. It is this one. Generally, metals do not show allotropy. We have tin. Example, this thing, tin does show, but generally. So here, bismuth does not show allotropy. So that's a very important statement. So what is the most important from the NEET JEE point of view? Bismuth does not show. Bismuth does not show allotropy. Okay, so this is the first and foremost. So when we come to nitrogen, now we're talking about solid nitrogen. Here, nitrogen has what you call two forms. One is called as alpha nitrogen, and the other is called as beta nitrogen. Allotropy is basically what? It is a difference in the arrangement of atoms in the molecule. So chemical property is same, but physical property is going to be different. And it is because of the difference in the arrangement of atoms in the molecule. So what is the difference in arrangement? That is the question. So what happens is, they have cubic crystal. So alpha nitrogen will have cubic. So we have done this in solid state. So they have cubic crystal structure, whereas beta nitrogen will be hexagonal closed package. So this is a fundamental difference. So this itself qualifies for a multiple choice question. They might even take it extensive and say you have beta nitrogen, the crystal lattice case. So what has happened is this question has included from what you call, see what they are trying to do is they are trying to combine 3 chapters together for one question. So this India, well, the beta nitrogen will have a crystal lattice on. So they have covered solid state and they have covered P block also. So that is the idea why these questions are important. Then when we come to what you call phosphorus, what are the allotropic forms we have? We have white or yellow phosphorus. We have white or yellow phosphorus. Then what do we have? We have red phosphorus. And then what do we have? We have black phosphorus. So what is the fundamental difference? All phosphorus molecule exist as P4. So between two P4 molecules, okay, what happens is there is, in case of white phosphorus, van der Waals force. Okay, in red phosphorus, what is going to happen? Between two P4 molecules, there is going to be a covalent bond. There is going to be a covalent bond between P4 to P4. What happens in black phosphorus is slightly difficult, what do you call the diagram I'm trying to draw. You know, my regular students will know that my diagrams are little pathetic. So the arrangements is like this. Something like this is the arrangement, okay? So black phosphorus, one very important point, difference in physical properties. Black phosphorus is a conductor of electricity. Generally, non-metals do not conduct electricity. So black phosphorus does conduct. So that will be which phosphorus conducts electricity. So black phosphorus does conduct electricity. Then we have arsenic. Nitrogen, phosphorus. Then we have arsenic. Arsenic exists in gray metallic. Arsenic will be gray metallic. And then you have yellow and black. Yellow and black. Nitrogen, phosphorus, arsenic, antimony. So what can we say about antimony? It is yellow or alpha antimony, and this is also called, the other one is called as explosive antimony. And the story ends there. Why? Because bismuth does not show. So please take down this much. That's good. Okay. Now we come to the next point, that is oxidation state. Now we come to oxidation state. So you know what is the definition of oxidation state? It is the charge carried by. It is the charge carried by an atom in a compound. By an atom in a compound. So it is stopping today at what you call oxidation state, because after this what we have is chemical properties. So tomorrow, for those who are in this live stream, the lecture will be at 6 o'clock, okay, 6 to 7. So Monday, Wednesday, Friday, we have lectures 6 to 7, and Sunday we have 5 to 6. It is clear. So we will be completing this whole month, and the next month we will be taking on these days to complete 15, 16, 17, 18, okay? And if there's anything different, then you always look at the, what you call, our YouTube channel. We'll post a message there for you. It is clear. And my regular students need not worry, because they are in close contact. So, and I would request all the people who are watching the live stream to tell their friends, since this is a pro bono, or what we say free service for inorganic chemistry. I want maximum people to, what you call, enjoy the live stream. Okay? I mean, This is something what our company and Elevate Plus can do for you. So it is a charge carried by an atom in a compound. So when we look at group 15, what happens is the most common oxidation state are. The first point is, the first question that they can ask is, the most common oxidation state are. The most common oxidation state are what you have -3, then you have +3 and +5. This is a decreasing. Okay, -3, +3 and +5. But what happens is, now +3 oxidation state, as we go down the group, the second point, as we go down the group, what happens? +3 oxidation state increases. Stability of +3 oxidation state. Stability of +3 oxidation state increases. Okay, and that of +5 decreases automatically. Now, why? That's the question. This is because of what we have learned in 11th standard is inert pair effect. Now, what is this inert pair effect? So, we have nitrogen, phosphorus, arsenic, antimony, bismuth. Let me explain. So, what was it that we had? If you remember here, okay, you had 1s2, 2s2, 2p3. Here you had 3s2, 3p3. Here you had 3d10, 4s2, 4p3. Look at bismuth. Now what happens in bismuth? You had 3d10, 4d10, 4f14, correct? 5d10. Okay. So literally, how many electrons in the D and F? You can say 10, 20, 30, 44 electrons. So bismuth was 83, out of which 44 electrons are in. So the outer electronic configuration was 6s2, 6p3. 6s2, 6p3. So 44 electrons are in D and F subshell. So when 44 electrons are in D and F subshell, D and F subshell are diffused. So if they are diffused, what are they going to do? They are not going to protect the, they do not protect, or they do not shield, not protect, let us say shield, that's the right word. They do not shield the outermost electron. They do not shield the outermost electron from the nuclear pull. So what happens is 83 what you call protons present in the nucleus up to 6s2. The pull is very strong. So you cannot remove 6s2. What is available then for removal is 6p3. And these also, like S, when electrons are in S and P subshell, they shield or protect the outermost electron from nuclear pull. That's called a shielding effect. Opposite of shielding effect is inert pair effect. What is happening? As more and more electrons come in the D and the F subshell and they don't protect, the nuclear pull on the outermost electron increases. When the nuclear pull increases, automatically removing the electron becomes difficult. So higher oxidation state means you have to remove this 3 and this 2 also. Now, So this 3 becomes easily removable, but this becomes a little difficult. So plus 5 becomes unstable, plus 3 becomes stable. So this is inert pair effect. So what happens is, so this is what is, I have explained to inert pair effect now, because again 16, 17, 18 we will be coming across inert pair effect. So what is inert pair effect? As we go down the group, the number of electrons in the D and the F subshell increases, and what happens? They do not shield or protect the outermost electron. So nuclear pull on the outermost electron increases. So removal of electron becomes difficult. So lower oxidation state only can be achieved. Higher oxidation state is what you call less stable. More stable is lower oxidation state. So as we go down, what happens? Plus 3 oxidation state increases. It's clear. Now, one more very important point is, nitrogen is the only element. Nitrogen is the only element which can show all oxidation state from -3 to +5. So you have -3, -2, -1, 0, +1, +2, +3, +4, +5. So you have stable compounds in all these oxidation state for nitrogen. So -3 is our old friend, what? NH3. Then this is N2H4, hydrazine. Then you have ammonium hydroxide. Of course, nitrogen. It's clear. Then you have N2O. Then you have NO, HNO3, HNO2, sorry, NO2, and you have HNO. So you can see stable compound. So this is an MCQ that they can ask. In group 15, among the following, nitrogen, phosphorus, arsenic, antimony. So ABCD ho gaya. Which shows compound, or which exhibits compounds in all oxidation state. All oxidation state, you will wonder what is all of them. All oxidation state is -3 to +5. So this is another MCQ. So you please take down this and you can exit the, what do you call, the stream. So tomorrow, for those who have joined our live stream today, we meet once again tomorrow at 6 o'clock. Thank you very much. Good night.